Hey guys, Mr. Riz here to help you out with the second part of the second quarterly review. We'll be going through all these questions here. So remember, this is just to help you guys get prepared for the quarterly that you guys will take. All right, so going through the second part here, we need to solve this first question here. Solve 5x squared equals negative 40. It's a question mark, I guess. I don't know why I found that so funny. It probably should be a period there. All right, so if we wanted to get x, figure out what x is, let's isolate it by dividing by 5 first. All right, when we divide by 5, we get x squared equals negative 8. All right, and then what's the easiest thing to do if it's just an x squared is to take the square root of the other side. A couple things to remember here is when we take the square root, anytime we do that, we're going to have a plus or minus sign to indicate that there's a positive and negative version. So that's how we get our two answers for x squared. The other thing is, okay, what to do when we have it negative? Well, what we need to do here is, we'll see, is there a square root of 8? Not really a nice one. So that means we got to break it down. The other thing is, if we have a negative, it means we're going to have an I with our answer. So if we're going to break down 8, 8 is 4 times 2, 2 times 2. So it means we have a pair of 2s. So 1 2 gets to go outside. The other 2 stays inside. And then we have an I because it was a negative 8. And so here is the answer for number 1. It'd be plus or minus 2I radical 2. Kind of crazy, but it goes over all situations here. All right, next, there we go. We use the quadratic equation to solve this and describe the nature of its roots. Okay, so quadratic formula is, if you don't know it, it's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So we got negative b is 2 plus or minus the square root of 2 squared minus 4 times a is 3, c is negative 5, and then over 2 times a is 3. Okay, so let's start to simplify this. We got negative 2 plus or minus the square root of. Got to square the 2 first, and then multiply. Negative 4 times 3 is negative 12. Negative 12 times negative 5 is a positive 60. That's awesome. All over 2 times 3, that is 6. All right, then we'll add the square roots together. That's 64. And then we will take the square root of 64, and that's great because that becomes 8. All right, so we have two answers here. One is negative 2 plus 8. That'd be 6 over 6, which is equal to 1. And then negative 2 minus 8, which would be negative 10 over 6. And that does reduce to negative 5 over 3. So we would have two answers here. One would be 1, one would be negative 5/3, and we would have two real roots. All right, so remember there's 3 options we can have with quadratic equations. We can have 2 real roots like there, so 2 answers that come out. We could have 2 imaginary roots, and it's basically the same thing except for this quadratic or the square root here would be a negative. Or we could have one solution. The only way we could have one solution is if the square root is of 0. All right, next, let's go ahead. I'm going to need a little bit of room here, so I'll clear this off. All right, write that equation in standard form. State the degree and leading coefficient, also divided by x plus 1. All right, let's do this here. So first, let's rewrite this in standard form. So standard form, we got to start with the highest degree here. So that would be 2x to the 4th. Then go down to the next power. We have negative 5x cubed. All right, then we'd have 53x squared. Now, this next part we kind of don't need to have, but I'm going to put it because we are going to divide. We do have 0 x's, and then we have a minus 4. All right, so the degree of this is degree 4, and the leading coefficient is the number in front, 2. All right, now if we're going to divide by x plus 1, we can actually use synthetic division. That's actually a whole lot easier here. So synthetic division, we put negative 1. Remember, it's whatever makes this equal to 0. And then we put down our leading coefficients. We got 2 -5, 53, 0, and -4. We drop down the first number and then we start multiplying and adding. All right, 2 times -2 is -2. If we add that together, that's -7. All right, -7 times -1 is +7. We add those together, that's 60. 60 times -1 is -60. We add those together, that's -60. All right, -60 times -1 is 60. If we add that to -4, that is 56. All right, and that's our remainder. So the answer would be, now remember, it always drops down a degree. So if this was 2x to the 4th, the answer here would be 2x cubed minus 7x squared plus 60x minus 60, and then a remainder of 56 over x plus 1. Okay, next, solve this by any method. We have 3 different ways we can solve this problem here. We can solve this by factoring, which is usually the quickest way to do it, but it doesn't always work out. We can do completing the square, which absolutely stinks. I don't like to do it, but we can do it, or we can use quadratic formula. So I would always recommend try to factor it first, because that's the quickest and easiest way to get nice answers. If it doesn't come out nice, then do the quadratic formula. All right, so here we go. What 2 numbers can we multiply together to get 24? Add together to get -10. And that would be a -6 and a -4. All right, so this would be an x minus 6 and an x minus 4 if we factor that. And then all we need to do is just set both of those equal to 0. And if I have x minus 6 equal to 0, that means x would equal +6. And if I have x minus 4, that means x would equal +4. Okay, next, combining like terms. So moving on to another chapter here, we're looking at different polynomials. We're going to look at common degrees here, and we'll add them together. So we got 5w squared, we got 8w squared, we got none over here. So that's just 5 plus 8, that's 13w squared. We don't change the exponent. All right, now we got w's. We got -7 plus 2 and then minus 1. So -7 plus 2 is a -5, minus 1 is a -6w. And then let's see, lastly, we have -6, nothing here, and then minus -3. So be careful here when we're minusing the -3, that's like adding 3. So -6 plus 3 is a -3. There we go, that's all we need to do there to simplify. Okay, next, simplifying. Okay, remember, when you are squaring a binomial or anything, what you should do is write it out twice. All right, so we're going to do 2x minus 5 times 2x minus 5. You're not going to distribute the square. You're going to have to distribute each term. So it ends up being a little bit different. All right, so 2x times 2x is 4x squared. 2x times -5 is -10x. Now here we got -5x times 2x, that's also -10x. And then -5 times -5 is a +25. Okay, so what we're going to do next is to go through and just combine like terms, which are these 2 in the middle here. So we got a 4x squared minus 20x plus 25. All right, next, factoring. All right, when we're looking for GCF, or greatest common factors, we're going to see, okay, what's the largest number we can divide both of these by? All right, I usually like to start with the smallest number here and be like, can we divide them all by 20? We can't do that. So then what's the next biggest number we can divide 20 by? Is 10. Can't do that. All right, so the next biggest number is probably 5. Yep, and that would be 5. And then we're going to look to see, okay, how many x's do all these at least have? They all have at least x squared, and so there's the GCF. So now what we're going to do is each one of these terms here, we're going to divide the number outside by 5 and drop it down 2 degrees here, because we are taking out an x squared. All right, so 85 divided by 5. I'm trying to do math in my head, but this is the first day after break. I believe that's 17. I'm going to have to use my calculator here. And let's see, 85 divided by 5. Yep, that's 17. And then x to the 5th drops down to x cubed. All right, plus 20 divided by 5 is 4. If we had x squared, we got rid of x squared, it just stays 4. Okay. And then minus, all right, 105 divided by 5, that's 21. Right? Yeah, it's 21. And then x cubed, if we got rid of x squared, just makes it a plain old x. So there we go. All right, next. Okay, this is a problem that we will definitely have to do. These were like the really long problems. We're going to have to find all the zeros and factors of x to the fifth plus x cubed plus x. Okay, so yeah, this is one of those problems too. Like if you try to use Mathway, it's so clear that you just do that because they do it a more complicated, well, I shouldn't say more complicated. They do it in an advanced way using some like pre-calculus techniques that you guys just don't know. So don't do that. Hopefully, if you're watching this video, you're trying to do this the right way. And I'm going to go ahead and put this up on Desmos. So remember, we can always find our real roots by where the graph crosses the x-axis. So I'm going to type that into the calculator here. Say, okay, and I'm going to click here. It looks like it crosses here at -2. It also crosses here at 1. Okay, so those are going to be two factors that we can divide by. And so if we're going to find all the zeros, so let's make a list of zeros. We have, we're going to have 5 of them because it's x to the 5th power. One is -2, another one is 1. And so that means some of our factors are x plus 2 and x minus 1. Okay, so now what we need to do is we need to take this expression here. We need to divide it down to make it smaller because this is x to the 5th. We got to keep cutting it down, and we can use synthetic division to make it smaller. So let's divide by, -2. And let's see, we have 1x to the 5th. We have 0x to the 4th, 1x cubed. We have 2x squareds, -12x, and then an 8. All right, so let's divide this down here to make this equation smaller. So we'll drop down the 1. 1 times -2 is -2. All right, and then let's see if we add that together, that's -2. -2 times -2 is 4. If we add that to 1, that's 5. 5 times -2 is -10. If we add that to 2, that is -8. -8 times -2 is 16. Positive, yep. If we add that to -12, that is 4. And 4 times -2 is -8, and that is 0. And that's happy because that is a 0 remainder. All right, so we dropped it down by 1. Let's do this all over again with the 1 here to make it even smaller. All right, so let's drop down the 1 here. 1 times 1 is 1. If we add that to -2, that's -1. -1 times 1 is -1. If we add that to 5, that would be 4. 4 times -1 is 4. If we add that to -8, it's -4. And then -4 times 1 is -4. If we add that to -4, that's 0. So there's our other root. So basically what we just did there is we turned this into, we dropped this down by 2 degrees once we divided by 2. And instead of being x to the 5th, this becomes 1x cubed minus 1x squared. All right, and then plus 4x minus 4. All right, so now what we need to do is figure out, okay, how can we find the 3 remaining roots or 3 remaining factors here and zeros of this equation? Now, it's not a quadratic, so we can't just use the quadratic formula, but we can go here on Desmos. We can see, hey, like maybe there's another one that we didn't see on our graph here. So I'm going to just type this equation in and see, okay, where does this cross? Oh, it crosses it at 1 again. So another 0 here, and this is why we couldn't really see it on the graph, is 1 again. And so another factor is x minus 1. So this means it has a duplicity of x minus 1. So that 0 happens multiple times. Okay, so let's make this equation smaller by dividing it. And I'm going to get a little fancy here because I can select and move some things around. And just, yeah, we'll put it over here. I'm just going to go ahead and divide this one equation by 1. Okay, so if I divide that by 1, drop the 1 down, we got 1 times 1 is 1. If we add that to -1, that's 0. 0 times 1 is 0. If we add that to 4, that's 4. 4 times 1 is 4. If we add that to -4, that's 0. All right, so that means our equation reduced to now, if that was x cubed, that is 1x squared plus 0x plus 4. Okay, so if we go to Desmos here and we try to graph this, that's basically x squared plus 4. That does not cross the x-axis, but that doesn't mean we don't have any zeros. It just means the remaining zeros are going to be like imaginary, and they're not going to come out nice. And so what we can do here is we can always solve this last part by using the quadratic formula. So x equals, we got -b, which, okay, that's 0, plus or minus the square root of b squared, 0 squared, minus 4 times a is 1, c is 4, and over 2 times a is 1. So we get 0 plus or minus the square root of 0 squared is 0, minus 4 times 4. Okay, that's 16 over 2. 0 plus or minus the square root of, that's just -16 over 2. Okay, so this is why it comes out a little nice. The square root of 16 is 4. So the square root of -16 is 4i. And then over 2. And then this reduces here. We can divide them both by 0. It's going to be plus or minus 2i. The square root, if we divide 4 by 2, that's just 2. 0 really doesn't matter there. So that means one factor is 2i. The other factor is -2i, or that's the zeros. And so we'd have an x plus 2i and an x minus 2i. And there's all 5 factors. So that one's a little tricky, but it encompasses everything we've gone over. All right, next page here. If you can do that last problem, the next one should be pretty easy here. All right, find all the zeros. That means we're just going to set each one of these things equal to 0 if it's already factored. X equals 0, that's already solved. All right, x plus 3 equals 0, so that means another 0 is x equals -3. And then x minus 4, if we set that equal to 0, that means x equals 4. Basically, if you had no idea, and if you even wanted to just go through on Desmos to graph that, you guys will be able to use a graphing calculator. If you just type that into the graph, the zeros are where it crosses the x-axis, and then let's see, it's at -3, 0, and 4. -3, 0, and 4, what we said. All right, next, identify the asymptotes. Well, if you want to use a graphing calculator, you can. We can go through here. X minus 2 plus 4. Okay. Or you can remember there's the equation here. The equation for a rational function here is y equals 1 over x minus h plus k. All right, or h tells us our vertical asymptote. And so we have a vertical asymptote when x equals 2. And that's right here. And so if I wanted to on Desmos, just kind of show you guys, I can go here and say x equals 2. You can see that. I think I can go through and make that like a dotted line. Oh, yep. That's definitely a vertical line that our graph doesn't cross. And then our horizontal asymptote is the number at the end of the equation, y equals k, which in this case is 4. If I wanted to do the same thing here, y equals 4. You can see here that is also another line that our graph does not cross. Okay, I think that's kind of it for Desmos, and I think the rest we can do. Yeah. Okay, next, if we wanted to divide, okay, what is the simplified quotient here? State any restrictions on the variable. Okay, so first off, what we need to do here is we need to factor these things. Actually, let's do this first part here. If we are going to divide by this fraction, that is the exact same thing as multiplying by the reciprocal. So that's the same thing as a plus 2 over a minus 5 times a squared minus 8a plus 15 over a plus 1. Okay, The other thing we need to do here is to look, okay, if we're going to multiply, we need to factor these things out to see. All right, so a plus 2 is on the top here. A minus 5, those do not simplify, or they're already simplified. We can't break them down. The only thing we can really break down here is the top here. What two numbers multiply together to give us 15, add together to get -8? And that would be x minus 3 and x minus 5, or a in this case. And then our a plus 1 is still just there. All right, so we're going to see here, is there anything that can cancel out anything on the top as it is on the bottom? And that's the a minus 5. And then so our answer here is just a plus 2 times a minus 3 over a plus 1. Now the restrictions here is just remember on the denominator, is there any number that you can have on the bottom here? And that's basically saying a cannot equal -1. That would make the bottom equal to 0. So that's the restriction part. All right, now simplifying. When we're adding or subtracting, we need to make sure we have common denominators. And it's always good to break down your fractions first before you try to make common denominators. So if we were just to break this down, let's see at the top, what two numbers multiply to give us 24, add together to get -10? That would be n minus 6 and an n minus 4. And then over here, what two numbers multiply together to give us 42, add together to get 13? Is that 7 and 6? Yeah. N minus 7, n minus 6. We're going to subtract 9 over n minus 7. Okay, so if we want to get these the same, what we have to realize here is that this fraction on the right needs to have an n minus 6. Okay. All right, so that means our top. Now, the common denominator is going to be an n minus 7 times n minus 6. We're going to have to simplify this top here and simplify this other top here and then combine them together. So let's see, the top is actually kind of nice because we know if this factors to this, it's just going to become an n squared minus 10n plus 24. I mean, if we went from here to here, we can go the exact same way backwards. Now over here, if we need to distribute a -9 to the n and the minus 6, we'd have a minus 9n and then a plus 9 times 6, that's 54. So let's see, this would be an n squared minus 19n plus, what's that, 78 over the n minus 7 times n minus 6. All right, then we'd want to see here, is there anything that could factor out here that could break it down? Is that 6 and 13? 6 times 13 is 78. Okay, so wow, this is why we did this, because this top factors to an n minus 13 times an n minus 6. The bottom is n minus 7 times n minus 6. And what ends up happening, doesn't happen all the time, but those n minus 6 cancel out. So the final simplified answer here is just n minus 13 over n minus 7. All right, next, when we're solving an equation here, what we need to do first is, before we start, let's say solutions that do not work. So we need to know right off the bat here, before we start doing anything, is that we cannot have n equals -1 or x equals -1 as an answer. We also cannot have x equals -5. Okay, so the next what we got to do is think, we got to get common denominators here. So this one over here needs an x plus 5. And this one over here needs an x plus 1. It's kind of easy because that's the only two ones that we have, but there we go. So once we got that, the denominators don't matter anymore. We're just going to look at the numerators. We're going to distribute the -4. So we got -4x minus 20 is equal to, distribute the -1. That would be a -1x minus 1. All right, so if we wanted to combine like terms, I'll move that over here. So we got -3x. If I add 1x over, if I add 20 over there, that would be 19. Doesn't come out nice, but we got 19 over -3, or -19 thirds. And there's our answer. All right. Last couple things here involving the imaginary numbers. Okay, we just need to combine like terms here. And so we'll start out with our real ones. Oh, let's distribute that. So we got 8 minus 6i. Let's distribute the negative. Minus 9 minus 11i. And then plus 6 plus 2i. And when we start combining like terms here, we get 8 minus 9, that's negative 1, plus 6, that's 5. And then negative 6 minus 11 is negative 17, and then plus 2 is a negative 15i. Now, when we multiply, we kind of do the same thing. We distribute here. 5 times 2 is 10. 5 times negative 3i is negative 15i. I times 2 is 2i. And then I times negative 3i is negative 3i squared. Now we can combine these here together to make a negative 13i. But the other thing we have to remember here is that I squared is equal to negative 1. So this negative 3i squared becomes a plus 3, which then we can add to our 10. Well, we get 13 minus 13i. All right, last question here is binomial expansion, which we have a shortcut, or what you can do is to write this out 5 times. All right, so the long way to do this is just to write it out 5 times and then to distribute it all. Or you can remember Pascal's triangle here. So we have 1 is the 0, 1, 1, 1, 2, 1. Okay, this is squared. 1, 3. We're adding those together. 3, 1. All right, and then we'd have 1, 4, 6, 4, 1. And then the one we're going to use here is 1, 5, 10, 10, 5, 1. All right, so we're going to have 1 times a cubed, or a to the 5th. So that would just be, if we actually take this to the 5th power, 2 times 2 times 2 times 2, that's 32 x to the 5th. All right, next we're going to have 5 first term to the 4th b. All right, so let's see. If we take the first term to the 4th power, that's 16. And if we times that by 5, that'd be 80. Oh, and I forgot. You know, maybe we should write this out because this one's kind of tough to do in a head. So we got 5 times, let's do, this would be 16x to the 4th, and then times b is negative 7. All right, next we would have 10 a cubed b squared. All right, so that'd be 10 8x cubed. That's what a cubed is. And then negative 7 times negative 7 is positive 49. All right, then we would have a 10 a squared b cubed. So 10, that would be 4x squared times, all right, 7 cubed, or negative 7 cubed is 343. Oh, I'm kind of rounding. Then we have 5ab to the 4th. All right, so be 5, 2x is just a, and then b to the 4th. 49 times 49 is 2401. And then lastly, I'm kind of running out of room here. It's just b to the 5th. So negative 7 to the 5th power. 2401 times 7 is negative 16807. Okay, so let's simplify this here. We got a 32x to the 5th is the beginning. And now the next one here, let's see, we got 5 times 16 times negative 7. That's negative 560. Oh no! Bell rang. All right, and then we can continue this off here. Let's see, 490 times 8. Can't see in the dark either. 920 x cubed, then minus 3430 times 4. 13,720, and then plus this would be 24010x, and then minus 16,807. All right, guys, so there's the second part of the review. Watch this, and hopefully you do all right on the exam. All right, have a good one.